All right, class, let's look at another arc length example. This one, though, we have x solved in terms of y. And again, our arc length formula that we use has f prime x and dy dx. Well, I got Shakespeare over here. Why do I have Shakespeare? It's because if you look at what it's saying, what's in a name? A rose by any other name would smell as sweet. Why does that apply here? I'm just calling the variable a name. I'm calling this x. I'm calling this y. What does it? It doesn't matter. All this does is it takes, the way the math is done. If this is y equals x squared that everybody knows, well, this is x equals y squared. It just does a rotation. It's still mathematically the same type of structure, and the procedures and everything are the same. So all that means here is instead of taking the derivative with respect to x, we're just going to take the derivative of x with respect to y. Treat y as a variable, and it's just a variable substitution. It doesn't matter what we call x and what we call y. All that matters is, this is the dependent variable, and this is now the independent variable, and the math is still exactly the same. We just make that slight adjustment that this is now x, this is now y. X becomes y, y becomes x. And that's all you have to do. So we have to do dx dy here. So this is going to be, think of this as 1/39 y cubed. So this is going to be 3 over 39 y squared. All right. And then this is y down at the bottom. That's 13/4 y to the negative 1. So now this will be negative 13/4 y to the negative 2. All right, 3 over 39 will reduce to 1/13. And now we square this. Dx dy gets squared just like we did in the last one. We square these. All right, squaring 1/13 is 1/69. 1/169th. Y to the 4th. Outside, inside, you can see what's going to happen here. I got 13 y squared times negative 13/4 y to the negative 2. So when I multiply these, the y's are going to cancel, the 13's are going to cancel, and I'm going to have a negative 1/4. Okay, remember that's outside, that's also inside. So I'm going to have two of those, so that's going to be negative 2/4 or negative 1/2. All right, and then lastly, I'm going to have plus, this is going to be 169 over 16, and that's going to be a y 4th power. All right, so there's the dx dy squared. We add 1 to that, just like before. That's going to add that to a 1/2. And we're going to have 3 to 5 square root of 1 plus this will be a positive 1/2. So 1/169th y to the 4th plus a 1/2 plus 169 over 16 y to the 4th in the denominator, dy. All right, and again, cherry pick. Think cherry pick problems. These problems have to basically, we have to be able to get rid of this radical or have some type of a perfect square under the radical for us to be able to do these problems. So think about what would, if this was going to be something squared, we have 3 terms, right? We have 3 terms underneath the radical. If it's something squared, then the first thing needs to be the square root of whatever this square is. So that would be a 1/13 y squared. And then this would need to be the square root of whatever this is. So that would be 13 over 4 y squared. Right? And if this is a perfect square, we know we would have the 169 y to the 4th. We know we'd have the 169 over 16 y to the 4th. The outside and inside would need to be a 1/2. So 2ab, the product of these. So 1/13 y squared times 13 over 4 y squared. They're going to cancel. They're going to cancel. 1/4 2 times is 1/2, which is what they have in the middle. So that's what we have underneath this radical, is this perfect square. So the square and the square root are going to cancel, and it's just going to give us the 1/13 y squared and the 13/4. I'm going to write it as y to the negative 2 for the purposes of integration. All right, so again, that's just like the one we just saw. We had to have that perfect square underneath it to get this radical to simplify away so we can do the integration. All right, so this is 1/13 y cubed over 3. And then this is 13/4 y to the, again, add 1, divide by the new power. -1 over 1. We're plugging in 5. We're plugging in 3. So this is y cubed over 13 times 3 is 39. All right, this is a negative right here. So negative minus 13 over 4. And then y to the -1 will go down with the 4 and just be y. Okay, again, we're plugging in 5. We're plugging in 3. So this is going to be 5 cubed over 39 minus 13 over 4 times 5. All right, now plugging in 3, but subtracting. Remember, we always subtract when we plug in the bottom. So minus 3 cubed over 39. All right, minus a minus will be plus 13 over 4 times 3. All right, then plugging all that in, I get 383 over 130 as that arc length. All right, there I am plugging it all into Desmos. You can use y's for Desmos just like you can use x's. So there it is. There's the fraction button. You can press that button to see that we get the same thing. So there's the setup in Desmos. There's what I got, and I can make them match up and show that I get the same thing. So Desmos, again, a great way to check your answers. But again, you need to be able to do the work. Just know that these arc length problems, a lot of times you're going to have that perfect square trinomial that you got to factor to a binomial to get the radical to go away.